Okay, in here you have this version 6 Braumat with all the additional add-ons or apps in Braumat, which is not in the standard. Yeah. I make it in version 6 because many systems are still running in version 6. So you can take it, but you can easily transfer or convert it to version 7. These tools are running in version 6 and version 7 as well. Yeah. Okay. Okay, let's start from the beginning. What means from the beginning? Brewhouse overview. There is a picture to show you that you can show in Braumat a lot of elements in one picture with good performance. This is a complete brewhouse in one picture. And maybe the client likes it to have everything together, including the units. Also the units, you have the units in here, all the elements, the temperature, complete for a widescreen monitor or for a beamer, I don't know, to have it all together in one picture. Looks nice. Yeah, you can do it. It's possible. I'm going now a little bit for the cellar functions and later on for other functions. The cellar functions, you have one for the tank cooling. It's called tank temperature control. Tank temperature. And you have a tank. Maybe you can use this function, which is used already in several breweries. You can have this 8 different zones for one tank. And you not only need to configure which output is linked to this cooling zone, and then this tool is doing the cooling for you by itself. Yeah, I show you. Yeah, here you see the tank, the according valves, and the temperature. These elements, they have to be linked to this tool. How you do that? You do this by parameterization. Let's go to the parameterization. Parameters. Oh. Thanks. Oh, it's not, I don't see it in here. What is going on? Maybe I forget it. But it's no problem. We can simply easily integrate it in Braumat by taking it from the library. There is one library in this folder. It's called add-ons. Tank temperature control. WinDCS, PCU, blah blah blah. And this data should be in the Braumat folder. This tank cooling, this is the description for the DB. So we have the PCU number 001. In fact, it's not in here. It's not in here. I don't see it here. And these other 2 files also need to be copied to there. It's strange that it's not in here. Huh? So we stop Braumat, we restart Braumat. I take this one from the library of all the tools. Now Braumat is starting, and if we are lucky, we have this tank cooling available now. Tank cool. You see, this is new. This is integrated in Braumat from the tools library. If you open it, you see the different tanks. Here it's 34, but it can be 64 or 128 tanks. It can be many different tanks, and each element is designed for 8 zones. You can have 8 different zones. That's quite a lot. Normally it's only 3 or 4, and you have to supply this by your specific data. Yeah. That means the level of the tank. You have to give here the analog input for the tank level. If you have a level of the tank, otherwise you get it from somewhere else, from a dB. Let's say this one is a tank level. Okay. And here are the signals. Activate cooling to switch it on. You need to enable this flag to get it switched on. Activate maturation. Activate fermentation. That means in the steps of maturation and fermentation, the cooling strategy is a little bit different. I can show you later on a PowerPoint. You have a different strategy for cooling. That means, let's say during fermentation, you try to have these upper zones being switched on. And later on, only the upper one, and the lower one you switch it off. Then you ensure circulation. And in the, let's say later on, storage and so on, you switch on the lower zones and switch off the upper zones. Yeah, this ensures a better quality of the product. So there is also a status machine. Tank is clean, tank is sterile, to give the information about the status of the tank. Then there is a ramp. That means if you go from 20 degrees to 10 degrees, you can go slowly. And that's good for the quality of the beer. Slowly down, you can say 1 degree per hour. Or 1 degree or 2 hours to go to have a ramp for the temperature. Then you have to use. Pardon? This is not in, I think, not in PC7. They make it different. This is, yeah. And there are some more parameters about the hysteresis, about the pre-stop value, which you can input in here. There's a manual where you can get more information about that. And these flags you need to link for the ICM. You cannot input directly an ICM in here, but this one is the output of this one, and this one you link to your output. You need to make a program to check this flag on the right side to switch on the according output, the according ICM, which is, let's go here again, tank temperature. Here, this flag in here needs to be linked to this flag. Output low, output middle, output high. That's what you have to do manually by programming. The rest is done by Braumat. The complete cooling of the tank can be managed by this one, and you don't need to do more programming. To get more deep.
So, what you have spent time recently is almost done by Braumat.
Yeah, that's already, it's not in the standard, but there is a manual, and you can see these different strategies for cooling. That means it's not only cooling, it's more than that. Yeah, it has the sensor selection depending from the level. It's checking the level and is selecting the correct sensor. This is also integrated, and also the cooling zone. The according cooling zones, yeah? You see, during fermentation is a different strategy than during maturation. So this block also ensures that you have a specific strategy for a good cooling of the tank.
Yes, this one we are programming a lot for this one.
Yeah, but it's already there.
It's already done. Sorry that you didn't know it.
It doesn't have in the template of the Braumat, even in version 7.
They forget it. They forget it. They forget it. Simply forget it. Yeah. No, it's like that. Yeah. The other one is tank data. it's good for the tanks to have some data, which is also not in the standard of Braumat. Yeah, like here, the number of the brews, the quantity, the status, cleaned or filled. You have the different status of the tank. This is in Braumat. This you also have in the Braumat. But what you don't have, you have the different brews. How many brews in the beer, which order number, batch number, and for this one there is also an extra functionality which you can extract from this demo. It's a demo, and you get the demo and you can take it from here to have for last 10 brews the according information at what time, the quantity, order number, batch number, the date, the sort for the tank. Yeah, tank data for each tank and a visual display of the data in the stream is available if you need it. What you see in here is a double seat valve. A double seat valve is used frequently in the cellar, and the double seat valve has a flushing of the top and flushing down for cleaning. Yeah, there is a functionality in Braumat for double seat valve. You could use it, but it's not so easy to handle it. It's not so easy. You need to look at the manual and implement it accordingly. Or you make it like we have done it before with 3 valves, 3 ICM, 1 for up, 1 for down. And then you have a pulse generator which is generating the pulses for this during cleaning. Bum, bum. Yeah, that is switching from one to the other one. Top and bottom, it's also an add-on to generate the pulsing according to your requirements. That means maybe every minute, 1 second or 2 seconds, there should be a flushing during CIP. So this is a module which is existing already to handle this flushing of the ICM.
Yes, luckily in this project we doesn't have this box.
Okay. There is another one which is called Pulses, which was add-on, but now it's integrated in Braumat. In Braumat now version 7 you have these Pulses integrated. This can do a little bit more. Here's some more functionality. This Pulses block. That means you can also use it for the switch on the malt transport. There is a manual about integration, and let's say additionally to the standard block, this is able to switch on the conveyors one by one and switch it off again also one by one. This can be done with these pulses. You have 32 pulses in one element, and you can use it for CIP flushing of the CIP, or also for the malt transport to switch on the conveyors and the scale and so on in a specific row, in a specific way, and switch off again, pulses. What else I can show you? The profit bus diagnostic. I don't know whether you need it, but it's possible to get the information from the profit bus partners about their status, whether they are in fault or one input or output card is not working. This is a template. This is a tool you can use in Braumat. You have all the stations. You can see where the one station is in error, and you can switch to the parameters to have more specific information about that. You see here, DB slave function. Okay, it's wrong answer from slave, wrong configuration, and so on. So if you have a big plant and there is any one of these profit bus partners is not working properly, You can see alarm by here, and then you can go there and get the specific information. It's also a block you can integrate in your Braumat system. Profibus diagnostic, very nice. The silo manager. If you have a brew house and you can make the calculation for the quantity in the silos with this tool without programming. You only say which input you're using. Let's go back. Manual parameters. Okay. In this one, in here, you say for the inlet of this silo, I'm using the ICM number 10 or the ICM number 5. And the counter is a DFM 0.10, for example. It could be the same for the tanks. Filling of the tanks, emptying of the tanks. To calculate the quantity according to the elements and the DFM. Yeah, when the inlet valve is open and the DFM is counting, then the quantity in the silo will go up. This information is enough. Yeah, if you select this information, the DFM, the ICM, then already it starts to count in when the valve is open. When it's empty, you give the empty signal of the silo, and when it's empty, it's resetting the value to 0. And when it's full signal, we don't have a full signal. But we can have 2 lines. We can say this inlet of the silo is by 2 lines. That means why we have why we have 2 different inlets, and also we have 2 lines for the output. It could be that they are going on 2 lines, so we can have this or this one. This or this to make the proper calculation, which will be in here. Here you have the calculation of the according value for the silo without doing any programming. So in case in your project this is a full signal, the full signal is setting the value to the max value, to the maximal value, and the empty is resetting it. And this one is a bar. So in this you see the quantity as a bar in here. You can see it in here. So you can edit the names to give the file is not existing in here, that you can write this one is a silo number 1, silo number 2, or you can give specific names for each silo. That's not enough. In the silos you want to know what is inside. It's like the tanks. Small silos here, for example, you see a silos, you want to know the delivery, from which supplier it is coming. That means this tool is doing the calculation from the quantity, but it's also doing the management of necessary information where the malt is coming from. Let's say the date, the time when the silo had been filled. So this data can also be managed by this tool. You have different deliveries, different suppliers, the sort, which sort is in the silo, which malt, beta-glucan, EBC, actual value, and so on. All this data is in the DB, in the data block, and can be managed for each silo. Okay, that's about the silo manager. In Braumat, let's say in the breweries, Danfoss variable speed drives are used frequently. Many times you have these Danfoss VSD variable speed drives, and for this one also we have a functionality. Oh, it's also not integrated. Not yet. We can do it to manage it by Braumat. I can show you how easy you can VLT, WinDCS, and you copy all what is in the PC001 to here. This one. And also this too. So we restart Braumat, and then we will have this VLT, variable speed drive. In here. Okay, this is the data set for the VLT, for the Danfoss VLT. Maybe in your brewery it's the same. What is important is the set point, where the set point is coming from. That means the 0 to 100%. And the periphery address. This is a communication by Profibus, but it's the same by Profinet. You can use it for Profibus and for Profinet. And this corresponds to the address from your hardware configuration, which address is assigned. Here you can say which protocol is used. Here's number 4. It means 4 bytes, 12 bytes, 12 bytes. A specific protocol, it has to be the same like on the variable speed drive, like on the Danfoss. On the display, you have to set the protocol which you are using, and it has to be the same like here, that they can communicate with each other. Release dataset. This is from the slot in which the CP443 is connected, in which slot. And this one is a slave number, the number of the slave of the Profibus. These parameters have to be supplied, and then also a ICM. We need to define the ICM, where it is linked, to which ICM number. You input it in here, and then when this is activated and you give a set point, the Danfoss will start up. And giving some feedbacks. There are some feedbacks in here to give you information about the status of the motor, whether it's broken down or something else. You get it from here. So in this way, you can very easily manage VSD, variable speed drives.